what the first derivative of a function can tell you is not only where it has potential maximum and minimum points, but can also tell you intervals where the function is increasing or decreasing. So for this polynomial, the first derivative is 6x squared minus 6x minus 36. And if we set that equal to 0, first of all, we could factor a 6 or divide everything by a 6, giving us x squared minus x minus 6 equal to 0. And that factors into x minus 3, x plus 2 equal to 0. And that gives us critical points of negative 2 and positive 3. And on those intervals, we can determine actually in between the critical values where the first derivative is either positive or negative. So in the interval less than negative 2, we would think of a number less than negative 2, like negative 3, for instance. We would have a negative times a negative. That would give us a positive in that interval. And we don't care what the actual value is. All we care is whether it's positive or negative on that interval. So, thinking of any value between negative 2 and 3, like 0 for instance, we would have negative times positive giving us negative everywhere on that interval for the first derivative. And then for any values greater than 3, like 5 for instance, we would get positive times positive, positive. And what that would tell us is that would tell us actually that the function is increasing on the interval from negative infinity to negative 2, decreasing on the interval from negative 2 to positive 3, and then again increasing on the interval from 3 to positive infinity. So what does that actually mean for us graphically? So if we look at the graph of the function, this is what the function approximately looks like. It's going to be increasing on the interval from negative infinity to negative 2, increasing everywhere there. It achieves a local maximum at x equal to negative 2. It's decreasing on the interval from negative 2 to positive 3, and then again increasing on the interval from 3 to positive infinity, achieving a local minimum at x equal to 3. Because that's what the derivative is. The derivative is the slope at the particular point everywhere on the function. So we see the slope is upward when the function is increasing. The slope is negative or downward everywhere where the function is decreasing. In other words, when the derivative is negative. And then the slope of the curve is upward everywhere where the function has a positive derivative.